Hello once again. We are back today with the section 2 on the tutorial section. Given a data set with the variables on class, first class, upper, lower, third, and pass of grade 1 by gender male, female, write our codes for a clustered bar chart and then stacked bar chart. Alright, so we are going to write our code to plot this data set containing the class obtained by students in a particular university. So we have 5 classes: first class, upper, lower, third, and pass. And we have males and females as students in that school. So we take them one after the other. Okay. So for A, fasted. So to be able to plot your graph nicely, the way your data frame has been arranged is very critical. Very, very critical. So let's say you have a data where you have the first class students, okay, their frequency. So maybe males who had first class were 20, females who had first class were 30, males who had upper were 40, females who had upper were 10, and so on to the last class. So when you have a data set like that, you have to reshape it or restructure it so that you can easily plot your graph. So doing that, we get the bar plot matrix. So this matrix helps us to easily get the whole values be plotting. And then, so when we talk about the bar plot matrix, something like you have male, you have female, okay, and we have let me add another one. We have first, we have upper, we have lower, we have third, and then we have part. Okay. So having matrix like this where the count of males who had upper, first, and so on are known. So let's say 40, we have 20, we have 10. Let's say 20, and then 30. And for females too, we have 50, 10, 25, 13, and then 32. Okay. So regardless of the data set given, we need to tweak the data set to form a bar plot looking like this, a bar plot matrix looking like this. And this will help how to plot your bar chart, either your clustered bar chart or your stacked bar chart easily. All right. So you have columns of class obtained, columns of gender, which is male or female. Okay. So you can use our code to just find the count of all males in the first class section, all males in the upper, all males in the lower, all males in the third, and so on for females as well. And you get that data, you can just write a code to get this bar plot matrix. So now we go on and write the code to get this bar plot matrix. So we're going to name that matrix as metric. We are going to assign it to so we have the X tab. Okay. So the essence of this X tab is we are using the data given to construct a contingency table like this. Alright. So you can either use X tab or T apply or reshape. And so depending on the function you use, it has effect on how you write your code. Alright. So in this code, we are going to use X tabs. So using X tabs, we have count, right? We have the dwindle. Very difficult to get that symbol. So we have count, then following gender plus the class. Okay. Then you have data equals the data frame name or your file name that you use to save your data. So maybe in our case, we use graduating class underscore class. Alright. This R code will reshape or create a contingency table from the data we have. So bear in mind, this question just said for a given data set containing the classes obtained by males and females in a particular graduating year, right? So you can just find the frequency of males who had first class, who had upper, like that, and now you create the X tabs for that, the contingency. And to do that, your count is the variable name for the column that holds all the total number of males in all the various classes, same as females. Your gender too contains the male, female, male, female, male, female, and so on. And the classes is the column containing the first class, upper, lower, third, and pass. So this code will create the X contingency table, right? And now we have something like this. So the code, this code after running will generate this table. And when we have this table, we have named it as what? Matrix. When we have this table, we can easily plot a clustered bar chart or a stacked bar chart. Okay, so we now move on to the R code to plot the clustered bar chart. So a clustered bar chart is a type of bar chart that has the bars aligned side by side but containing more than two categories. Okay, so in this case, gender, we are going to classify the bars with respect to gender. So the x-axis will hold males and females, and the y-axis will be the count of the total number of males, total number of females in each classes. Okay, so the name is bar plot. Okay, we are writing our R code. So we are back to the name we gave to our metrics contingency, and the name was metrics because that's what we assigned the contingency table to. So metrics, comma, right? We have since we are plotting the clustered bar chart, the bars will lie side by side. So beside is equal to true, comma. So we are plotting the bar chart with the data found in the metrics data frame. And then we want the bars to lie side by side. That's why the beside is equal to true. And then we will name our x-axis as class, and then our y-axis as count. Okay. So it's supposed to be in small cap. So we have x lab equals class, and then y lab is equal to count, and close the bracket. You can add something like a color code to your bars. Maybe red should stand for females and blue should stand for males. You can do that using the COL function. So you can just add it somewhere here, that COL okay, equals, then small c, bracket opens. So one bar should be blue and the other should be yellow. Close bracket, then comma. Alright, so this code will plot a classed bar chart from the contingency table we did from our data matrix. And now beside is telling how to plot the bars on each side. So you have the true here. And this color, the color function is making one of the bars blue for the first gender and yellow for the second gender. And our x-axis will be the classes. So we have first class, second class, third class. So first class, lower, upper, third, and what? Pass. Representing maybe all yellows representing females in that section, all blues representing males. Alright. So this is the R code to run that. Alright. And the second question was a stacked bar chart. So the difference between a stacked bar chart and a classed bar chart is that with stacked bar chart, the various components will be packed on top of each other. So the only difference you're going to have will be with respect to the beside. Okay, so in stacked bar chart, the beside won't be true. Instead, it's going to be false, telling her that you don't want the component bars to be lying on each side, but they should be on top of each other. Okay, so the only difference will occur at that side. We repeat the same thing, but then change the beside to false. So bar plot matrix beside equals false. So same thing, color equals C. Then we have blue, comma, yellow. Then our x-axis is the class, and then y-axis is the count. We close bracket. Alright, so this code will also output your stacked bar chart. All right, move on to the next question. The next question, we are going to prepare SPSS to receive data. Okay, and the data will come from the questionnaire in table 1 in the past question. So I'll quickly move to SPSS and also view the questionnaire which I'm going to use to prepare SPSS to receive the data. Okay, so this is a variable interface of SPSS, and then we have our questionnaire on our right hand side. Okay, so in the questionnaire, the first question is a gender. So okay, we have reference. It means we are going to number our respondents, so we can make that as our first variable. So reference. Okay. The moment you press enter, it fills all the other columns for you. So reference is going to be a numeric data because it will be 1 to infinity or to the total number of respondents to be taken. And then the width of the number. If you are taking, let's say, in the 1,000, 10,000, depends on the total number of respondents you're expecting. So this width 8 here means that you'll be having 8 zeros. Okay, so you can either increase or decrease. So if you are expecting about 100 plus respondents, you can make it 3. Okay, then decimals. We don't expect any decimals here, so 0. So the label is a full description of the variable. So you can just say reference numbers of respondents. Values here, we use this column to recode any coded responses. So for our reference column, you don't need any coding, so we leave it blank. If you have any missing value, this is where you type in it in the columns. Let's make it 1. So since the values you'll be taking are numeric data already, so it is right aligned. It normally does it for you. When it chooses string, it changes to left. And the measure, reference numbers, they are ordinal because we move from 1 to 2 to 3 to 4, so it's in order. And just make it ordinal. And the role here is supposed to be input because we are going to input the data. All right, so we now move to the next question, gender. So gender, you can basically make the reference the name gender when you hit enter. So gender, though the responses there are male and female, which are string. In our previous section, I told you that SPSS will require us to recode them in numeric form, where we said 1 will be male, 2 to be females. So over here, we keep the numeric type of data, reduce the width to 1 because it's either 1 or 2, which is 1 for male, 2 for female. So the width of the value is 1, and there are no decimals, so you can reduce that. So the label will be the full description, so gender of respondents. Then now values. Since you coded it when you took the data, okay, you need to recode it back. And you see that 1 is for male, you click on the add. 2 for female, you also add that. So in this when you open your data, or now when SPSS is ready to accept your data, SPSS will see 1 and 2 in the new data injected onto it, but will interpret 1 as male and 2 as female. We press OK, and then we come here. The measure is what? It's nominal because there's no order, and we cannot scale those numbers because it's irrelevant, so nominal. And it's also input. The role is going to be input because we're going to input the data. All right, so we move on to the next question, age. So age, hit enter. Of course, age is a numeric data. There's not supposed to be 0 because you don't have anybody having 0.5 years. So here, ideally, nobody is going to be more than 1,000 years old. So we maintain 2. So the highest age will be in the range of the hundreds. I come here. So the full description, age of respondents. We are not going to recode. So we maintain the values as none, missing. We have any missing value. We treat it as such. So age is going to be scale because we can get actual numeric values in which we can analyze. We move on to program of study. So we can just say study underscore program. So study program. We have that. And then study program, please, you are going to receive string values or non-numeric values. So we change that to string. Then the number of characters, we can increase that because we'll be taking maybe agriculture, mathematics, okay. So depending on the number of letters in each word, so you can make it, let's say 20 to cater for all of them. So just describe it well and see that's what program of studies by each respondent. Then we didn't do any recoding, maintain everything. Yes, everything is already given. So the next question is, do you vote? Also, in our previous section, we talked about coding yes, no, and sometimes to 1, 2, and 3. Okay, so our variable name is we can make it voter. So if you're a voter, it means you vote. So do you vote? Voter. Then numeric. You can make this 0 because we'll be having 1, 2, and 3. Make here 1. So the full description, do you vote? Okay. Then we come to our values. Since we coded yes as 1, no as 2, and sometimes as 3, we need to recode it back. So we have 1 here, we write yes. 2 here, we have no. And then 3, we have sometimes. Okay. So that comes nominal. What is your party affiliation? Your party affiliation, you'll be expecting alphabet, so we can make the name as just affiliation. We expect strings. But in case maybe in our Ghanaian setting, we have about handful of 10 parties, And if you're going to analyze anything on that, then we need to code or do something. So in that, if you coded, you choose numeric, but if you didn't, you still maintain the string. And you come here, give a full description, party of affiliation. All right. So we move on to which party do you intend to vote for? So our variable name can make it voting let's generate a very nice reference name. So which party do you intend to vote for? So you can make it vote _for. And we are going to have strings because having party A, party B, party C. Okay. So which party you are going to vote for? Right. So we move on then. All right. And on question 7, rate the following attributes of the voting method, circle as appropriate. We have 3 questions as a sub question to 7. So all those questions will also have variable names separately. So for the first question under question 7, we have Ghana must continue with manual voting. We can name it as manual _ voting. So manual voting, you'll be expecting numerical values since when you disagree, you're going to circle 1. When you agree, you're going to circle 3. And when you're on the neutral grounds, you circle 2. Just write Ghana must continue manual voting. When it comes to that, we need to recode and say that 1 was for disagree, 2 for neutral, and then 3 for agree. Okay. Ghana must adopt online voting. So online _voting. Enter numeric. So this can go to 1. Same for this 0 and then 1. So Ghana must adopt online voting. Since the coded values are same for all 3 questions, I can just copy this and paste for here. Okay. Same thing applies to all of them. And the last one is Ghana must adopt a hybrid voting. So hybrid _voting. Hybrid _voting. Enter. We have so Ghana must adopt hybrid voting. I'm going to repeat the same thing for the values since they are all the same. We copy and we paste. Okay, so we are done with this question. I want us to try something. Let us try renaming online voting as online space voting. Let's see. The moment we enter, it says variable name contains an illegal character. So a space is not allowed in variable naming, confirming what we talked about in the previous section. So always make sure you follow the right approach in naming your variables. We are done with question 2 on how to prepare your SPSS to receive the data. So you go to data view, you're going to have a nice column views where we'll be having our data in every column nicely. Okay, now continue with question 3. In our next question, we've been given a data set comprising of two variables, intelligent test X and final test Y. Outline the procedure for performing regression analysis using Minitab software. Unfortunately, my Minitab software has expired, so I'm going to do this in a theory way. Okay, so you have a data set containing two columns where you have your intelligent test X and final test Y. So you have some values under the column intelligent test and values under the final test. So to do this, you have to make sure you have cleaned your data very well. Okay, so you open your Minitab and then you decide whether to import the data. So if the data size is very small, you can key in the data yourself, or you just go and open from the file. So the first step is for those who are going to type it directly into Minitab. You're going to enter the data in Minitab yourself. You open Minitab, then you having a view looking like a spreadsheet application with cells arranged in columns and rows. Okay, so you take one column, you name it the intelligence test, you key in all the values. Also do same for the second column, final test, you key in all the values. In this case, your data is ready. Or if you are using the importing method, you open Minitab, you click on File in the File menu, then you go to Open Worksheet. When you go to Open Worksheet, you will be asked whether your file is CSV or Excel. You choose the file type which favors your file type. Then you click on the file, then import into Minitab. Now you are ready. But before one can undertake regression analysis, we would like to know if there's actually a relationship between these variables we are trying to find the regression analysis on. So to do that, we use the scatter plot to determine whether there is any relationship existing between these variables. So in Minitab, we need to do the scatter plot first, and when done, we continue with the analysis of the regression. So in Minitab, you click on graphs, you go to scatter plot, then you click on simple. Because we are dealing with only two variables here, the x test and the final test y, we choose on simple, and our y value will be the final test because it has been indicated as y, and our x variable will be the intelligent test x. Okay, then we click OK. When you click OK, there will be an output showing a scatter plot of intelligent test and final test. So visually, you can see if there's a trend in these two values. If there is a visible linear trend, a visible quadratic trend, a visible cubic trend, you can see that. Then we head on with our regression analysis. So when we look at it and we see that there is indeed a linear relationship between these two values, then we can go ahead with our regression analysis. Okay, so we now move on to the regression task. So to find the to do the regression analysis, we will move to Start in the menu bar. Okay, and from Start we go to Regression. Move to Regression again. Now to Fit Regression Model. So clicking on Fit Regression Model, a dialog box will open. and to ask for our variables. So for the response variable, it is the final test or the y, and our predictor is going to be the intelligent test bracket x. Okay. So when you select our two variables and we hit OK, the regression model comes out with a lot of metrics we look out for. We look out for the p-value, we look out for the r-squared, the r-squared adjusted, and now we build on that and conclude whether the regression model is statistically significant and whether it's able to, the predictors are able to explain the variability in the dependent variable where we use the r-squared adjusted. Okay, so this is all for question 4. In question 4, we have been provided with data named table 2 in appendix. So we should correct the data structure if you want to run any form of analysis of variance test. Let's take a look at the data. So we have this data containing the free SHS and non-free SHS, same schools, but we have scores of schools under free SHS, school A, B, and C, and school A, B, and C also having scores under non-free SHS. So how are you going to restructure this data if you want to run any form of analysis of variance? So looking at this data, we can restructure it by regrouping them. So the year, we had year 1 for school A for free SHS, same year 1 for school B for free SHS, same year 1 for school C and a free SHS. And we had it's year 1 for school A and a non-free, B non-free, C non-free. So we can have year 2 for school A, which is also having free SHS, and we have the respective score. We do same for year 2 for school B, year 2 for school C, year 2 for school A and a non-free, year 2 for school B and a non-free, and so on. So having this data, we can easily calculate or run any form of analysis of variance on it. So we have year 1 up to year 5, ABC, recurring for free SHS and non-free for respective years, and the scores as follows. So with this type of rearrangement, you can easily do the analysis of variance. The last question. Provide a syntax or code with specific argument for performing the following tests in R. 1. Pearson correlation, paired sample t-test, one-way ANOVA, chi-square goodness of fit or independence test, and a linear regression model. Provide the syntax or code with specific argument. So since this question is a sub of question A, which was provide a correct data structure for the data set in table 2, I think we can use the data set in table 2 as our specific argument to write the code in R for Pearson to the last one, linear regression. Hope you understand, because with specific argument, we cannot generalize the code, but with specific argument from these data points. Okay. So with Pearson correlation will test for the strength and direction of the linear relationship between any two numeric variables. Okay, and they must be they must satisfy the assumptions for parametric, since Pearson is parametric. So we assume that our data given is normally distributed, linear is a linear relationship, homogeneity of variance, and so on. Okay, so writing the code for Pearson correlation with specific argument using the data above, we can try and find the Pearson correlation between the score and the year, because given our data, the only numerical values you have is the year and then the scores. So we can find if there is any relationship, or we can use Pearson correlation to take the correlation between the year and the score. So the code is, we have COR. Remember, let me write it beneath it. COR for correlation. Okay, and then we select year in our data set. So year. Okay, so data is the name of our data frame given in the question table too. So data $year, it picks that year. Okay, and now the data for the other one too, we pick score. Okay, so we have these two data and we want to find the Pearson correlation. So our method will be equal to Pearson, and with this we can find the Pearson correlation of year and score. Do you understand? We move on to the paired sample t-test. So paired sample t-test, it compares the means, okay, of two things in the same group. So we can say that group A, we have non-free SHS students. School A, we have non-free SHS student there. Same school A, we have free SHS there. We can test if the means of their scores are significantly different, and you can use the paired sample t-test. Hope you understand. So if you're using the paired sample t-test, and it means that we are going to take the scores for free students and then scores for non-free students in a particular school, say school A. Okay, so now the code is as follows. So sample t-test, we have t.t test, okay, bracket opens. So in our data frame, you restructure it and have a column for free scores for A. So bracket opens, free underscore scores, and then non-free underscore scores. Remember that you are creating a new data frame where you keep or rewrite all the scores for school A under free SHS down in one column. All the scores for non-free SHS school A, all of them, you write it down. So when you write those new data set down, you write this test, comma, and paired is equal to true, meaning we want paired sample t-test. I made a mistake. So paired, we want the paired sample t-test. So in paired sample t-test, we are going to rewrite a new data frame where our first column will be free score of A, of school A. We can make it just score A, okay? And then non-free scores, saying that you want to compare if there's significant difference in means of scores of students in school A, students in non-free school A, right? We move on to one-way ANOVA. So one-way ANOVA basically tells the if there's a score, sorry, if there's any significant difference between 3 or more. Okay, so if there are 2, we use the t-test, but if there are 3 or more, we use the ANOVA. So we can save our ANOVA model to, let's say, ANOVA. Okay, we assign it to that. So our AOV bracket opens. We have score following the school type, okay, and we are picking the data from our data, which is table 2, if the name is table 2. Alright, so with this, you can find the ANOVA of the score, the school type. Since the school type, we have school type A, B, and C, making 3 schools. Okay, making 3 schools. We can use the analysis runs. If the schools were only 2, then we can go ahead with a t-test. But since we have 3 schools, the best test is use one-way ANOVA. So when you have this, you can output the ANOVA model here, and you get your result for the ANOVA. So output into bracket ANOVA. Okay, so with the chi-square test of goodness of fit or independence test, we can do a categorical test to see if there's any difference or any association. So if there's any association, then using the chi-square, we can take the school type and also the school. The school type, we have free and then non-free. That's supposed to be school ABC. So for the chi-square, we have a data point between school type and then school. So school type is non-free SHS and free SHS, and the school is ABC. You can find if there is any association. So with that, our chi-square, we have to assign a table to that. Okay, now table, our data, we are taking school type and we are taking school as well. Okay. Then we calculate chi-square test of the assigned table. On output, you get the chi-square test. And finally, the linear model regression. So you can assign model to this. We have the linear model regression. We have the score. We want to predict score. If you know the school type, the school, and your year, we want to use these predictors to predict the score. So following school type plus school and plus year. And you're taking the data from table 2. Okay, yes. So this code will run the various tests to give us the results. But we have the generic forms of all these codes. But pertaining to our question, we are providing the syntax with specific arguments. Alright, so thank you for listening. I hope you've learned a lot and you'll be able to write your exams and come out really happy with yourselves that you're going to pass data analysis 1. Thank you and have a good evening.